I'm particularly pleased and honored that I am chairing our first keynote presentation, which is given by Eric Yu. Eric Yu was the 2019 Peter P. Chen awardee. And, you know, when I thought over how I will introduce Eric, of course, you know all his achievements, his work he has done for requirements engineering, the iStar and foundations. But what you don't know, I will tell you now. To a certain extent, we have kind of sibling scientific grandfathers, and perhaps Eric Yu not even knows it. I was allowed to do my postdoc with Dennis Zichritzis some more than 30 years ago in Geneva. And you know, Dennis and John Milopoulos were working together in Toronto before, and John Milopoulos was visiting Geneva, and I got to know him, and I was able to also attend the seminar. And since then, I was very kind of also influenced by the work, and I, of course, followed the work of Eric Yu. So it's my special pleasure, Eric, to welcome you here at the 39th International Conference on Conceptual Modeling, and I want to hand over the floor to you.
Thank you, Gertie. Good to meet my academic sibling. That's very nice to know. And so first of all, I would say that my heart goes out to people of Vienna for the very sad event that happened. I think all the violence should be condemned. My throat, my voice is not so good this morning, so I will play the pre-recorded video and answer questions afterwards. And my face will show up on the video from time to time. It really is a great honor to be the recipient of the 2019 Peter Chen Award. First of all, I would like to thank Peter for his pioneering work. Your leadership has inspired us all to further advance the field of conceptual modeling. I want to thank Elsevier for sponsoring this award. I want to thank the award committee for choosing to recognize me and my work. I'm humbled to be named alongside the other award recipients who I greatly admire and have regarded as role models. And thanks to the organizers of ER 2020 for giving me this opportunity to give a presentation. I want to thank my co-authors for their wonderful collaboration. This award is an acknowledgement of your work too. There are also many others who have experimented with iStar, critiqued it, tried it out, applied it in different application domains, extended it in many different directions, and improved upon it. This award is for all of you too. One person that I want to recognize by name is my PhD supervisor and longtime mentor, Professor John Milopoulos. If it were not for John's unwavering encouragement and patient guidance, I would not be here, and there would certainly be no iStar. So thank you, John, from the bottom of my heart. Information systems and many other kinds of software systems operate in a social context. The idea of iStar was that one should be able to model that social context and analyze it systematically, just as one would model a technical system. But you need the right kind of abstraction for understanding and analyzing the social. With systematic modeling and analysis, one would be able to design better systems that work better within the social context. In the first part of my talk, I would like to quickly review how iStar offers a modeling framework for dealing with the social. Then in the second part, I would like to suggest that iStar concepts will need some updating to reflect the complex social realities of our time. As I was preparing for this talk, I reflected on how I arrived at iStar. In hindsight, I realized that I was just lucky to be at the right place at the right time, and therefore had the right influences from very smart people. So I'd like to begin by giving you some background about how I got into social modeling and how I ended up with R-star. During my student days at the University of Toronto, the computer science department was strong in many areas. In particular, John was already a leading scholar, active in the areas of database, information systems, software engineering, and AI, and was championing the idea of conceptual modeling. After obtaining my PhD, I joined the Faculty of Information at the University of Toronto, where my main appointment is today. Many of my colleagues are in the social sciences and humanities. The latest addition to our program is a concentration in human-centered data science that has made me think a lot more about the social realities that we face today. So how does one get from AI to social modeling? That was my journey. When I applied for my PhD studies, I thought I wanted to do AI. That would be called good old-fashioned AI nowadays. But during my studies, I was exposed to a very rich mix of ideas because of John's active engagement with all these areas. For instance, one of the influences that I had was Saul Greenspan's work under John's supervision. A key advance at the time for requirements modeling was SADT, the Structured Analysis and Design Technique of Douglas Ross. It offered a very elegant abstraction of complex systems in terms of inputs, outputs, controls, and mechanisms, and highlighting the duality between activities and data. What Saul did was he used conceptual modeling techniques to formalize SADT, but he also generalized it by adding assertions, which captures the declarative specification aspect of requirements. Later in this talk, when I give a quick overview of R-star, you see that activities and entities in RML became tasks and resources in R-star, and assertions became goals. And the fourth kind of element in R-star, soft goals, originated in Lawrence Chung's work on non-functional requirements, which was also supervised by John. So you can understand why I say that I was just lucky to be at the right place at the right time. But what about the social side of things? How did I get into it? Before I went for a PhD, I spent a few years in industry, in the telecom industry. I was involved in envisioning how digital technologies would create new opportunities for the company. I became sensitized to the enormous impact that we as technologists could have on people's everyday lives. So during my PhD, I was looking for ways to reconcile technology with the social and human dimensions. One area where the integration of social perspectives with technical system design was happening at that time in the area of office information systems or office automation. Some of the research results are recognizable in today's collaboration platforms and business process management systems. However, my interest was not on the technologies per se, but on the abstractions that enable you to think about how the technologies impact or interact with the social environment. One example of such an abstraction that received a lot of attention was the action workflow model. I mention this one because it was inspired by theories in philosophy and sociolinguistics, which shows the very interdisciplinary flow of ideas that was necessary to address the human and social aspects of technology. So that was the backdrop to the development of R-star, at least in hindsight. But now, times have changed, and we may need some new ingredients to make a new soup. So now let's take a quick look at R-star. What are the key ideas in R-star? How is it different from other modeling languages? The central concept in R-star is the actor. Actors have relationship with each other. That's the A for actor and R for relationship in R-star. Actors depend on each other to get things done. So the key questions for each actor are, what do I want? How can I achieve what I want? And who do I depend on to achieve what I want? The actors are strategic in that the dependencies create opportunities as well as vulnerabilities. So there are upsides and downsides to dependencies. R-star actors are intentional. They have desires, goals, and motivations. They have autonomy. They have choices. They have freedom to violate rules as well. So they're unpredictable. They are social. They have relationships with each other. They have identity. There is the self and others. They reflect on their strategic position in relation to others, and they try to advance their strategic interests. Note that the actor in R-star is a modeling abstraction. Agenthood is attributed by the modeler. That's in contrast with the intelligent agent in R-star, which needs to be implemented in software. As a modeling abstraction, the actor concept can be applied to humans, software, hardware, or combinations thereof. Just like in SADT or RML, the requirements modeling language, or other conceptual modeling techniques, it can be applied to completely unautomated activities. Here is a healthcare example illustrating the 4 types of dependencies in R-star. The key distinction between a goal dependency, like this one here, the patient depends on the healthcare provider to be treated for sickness, is that the dependee, in this case, the healthcare provider, is free to choose how to achieve the goal. With the task dependency, in this example here, the doctor depends on the patient to follow the treatment plan. So it's a specific way of doing something. So the task dependency does not give the dependee the freedom. You may recognize that the idea about how to specify freedom comes from declarative specifications in software. I mentioned earlier about assertions in RML. So it says the requirement makes an assertion about the outcome, the goal, but you, the programmer, is free to choose different implementations as long as you produce the desired outcome, i.e., achieve the goal. There's a resource dependency, and then there's a soft goal dependency. The soft goal dependency is where the criteria for achieving the goal is not clear-cut, but needs to be refined sufficiently for the depender to say it has been achieved. For example, whether trustworthiness or accountability is achieved by selecting the right methods, which can be context dependent. These are the types of dependencies further explained here. The same 4 kinds of elements are used to model the internal reasoning within each actor. The elements are connected by different types of links. There is the means-ends link, which connects tasks to goals. Here are 3 different ways to quell your hunger, to get fed. But are they equally good? Soft goals are quality objectives, which help you sort out which tasks are better with respect to which quality objectives. And these can be competing goals. So you have to make some trade-offs. Tasks can be broken down into constituent components so that you can make finer grained distinctions and analyze how each of them contribute to the soft goals as well. So a more complex example may look like this. This is a home care example. So what do you want to do with an R-star model? It's to ask questions like, is this configuration of dependencies among actors going to work? If there are important goals in some actors that are not satisfied, you would want to go back and explore further alternatives. Otherwise, if you went ahead to build the system, you would end up with problems or systems that are not used. This kind of reasoning relies on propagating values or labels throughout the network of dependencies between actors and the internal structures within actors. There are quite a number of proposals on how to do this kind of goal model evaluation. Here are some of the early references on R-star. A lot more work has been done since by many researchers. R-star has been applied to many different application settings. One of the early applications was to European air traffic management, and this was done by Neil Maiden and his team in the UK. Security and privacy is a big area that many researchers contributed to. Here is a sampling of the many publications in this area. Regulatory compliance is another one. These works have developed substantial extensions or have made modifications to the original ideas in R-star. A very interesting application was to analyze complex relationships in software ecosystems. In the risk costs project, R-star was combined with the risk modeling framework. Another fruitful area was in development methodologies for agent-oriented software systems. Since R-star is built on agent-oriented conceptual foundations, it is a natural fit as a starting point for building agent-oriented software. A recent study examined the many different extensions that have been proposed for R-star, and a process was proposed to make the evolution of R-star language extensions more orderly and consistent. One variant of R-star was adopted as an international standard, thanks to an initiative from the telecom industry and to the tremendous work led by Daniel Amiot. This work was summarized by the keynote talk given by Daniel at the R-star 2020 workshop in September earlier this year. Another initiative was to reduce the complexity of R-star to make it easier to learn and to streamline some of the language features. There has been many PhD dissertations done using or improving on R-star over the years. Some of these are listed on the R-star wiki website. Many software tools have been developed. So social modeling is a very active research area. The original R-star laid out some basic ideas, and many people have expanded on it and brought many new ideas. But now the world has changed and we face some new realities. We are living in exciting times, as the conference theme reminds us. Everything is becoming digitalized. Your shopping, your work, your healthcare, your social life, your news and entertainment, everything is at your fingertips and it's instantaneous. You say something, and your thousands of followers will like you, retweet you, or bury you. What you do, what you say, how you look, where you go, is all being analyzed and fed back to you by machine learning as shopping recommendations or video streams or news feeds based on who you are and what you like and what you would want more of. Here's a projection of the market for affective computing. That's just for the US. You can get an API now to do facial analytics and emotion detection. Cultural analytics is a thing, and there has been a journal on it since 2016. IT systems are now embroiled in the social conflicts of our times, in changing employment landscapes, in personal health and public health, in environmental sustainability. Every Google search that we do contributes to more carbon dioxide, in creating polarization in our politics, and even threats to what it means to be human. And these are the systems that we build. They are creating and shaping our new social realities. So how are the social realities of today different from those of the past? You might say it's just more of the same, but accelerated, magnified, and more interconnected than ever before, which would all be true. But in our I-star modeling, we abstracted out many of these complexities. So the question is, are the conceptual modeling techniques that we have today, such as I-star, adequate for handling the social realities of everything digital? What kind of abstractions will be useful for conceptualizing and building digital applications that will be viable in light of today's complex social realities? I would like to offer a personal perspective. I suggest to build on I-star foundations rather than start from scratch. Social actors today perhaps have even stronger opposing interests than in the past. What's different is that they are fighting over their differences using the full power of digital technologies. But digital technologies can bring a lot of benefits too, if we know how to use them wisely. I'm suggesting that to deal with the complex realities of today, we would want to explicitly model and reason about beliefs, values, and emotions, and maybe other things, and be able to handle localized contexts as well as continuous change. And we would need to look more closely at potentially multiple levels of abstraction for actors. In I-star, the focus is on goals and how goals can be achieved. But now, actors' beliefs are being challenged and can be influenced by digital technology. Further, data analytics models are used to generate insights that shape beliefs. Conceptual modeling needs to take the dynamics of beliefs into account. How do beliefs propagate in a social network? How do actors choose what to believe? These are important to include in conceptual modeling in today's world. With cultural analytics, you are now able to determine what people value in their lives. What are their core values? What's considered good or bad? What's worth standing up for? These are already widely exploited in marketing campaigns and elections, again, through digital technology. Malicious actors can also exploit knowledge about your values to social engineer their attack vectors. Our emotions are now readily accessible to digital applications. Social media platforms exploit our primal emotions to get us addicted to the never-ending newsfeed, or the funny videos, or our friends' reaction to our every move? How do we reconcile emotional reasoning, if we can call it that, with the rational thinking that we have assumed with the strategic actor in our star? How do we account for people's behavior that appear to be going against their own self-interest? What are the semantics of emotions? Cognitive scientists have been studying different brain functions that lead to different kinds of behavior. How can we accommodate different kinds of cognitive processes in a conceptual modeling abstraction of the social actor? What are the different types of emotions? How are they triggered? How do they determine action? Here's a classification of emotions. And here's an early effort in formalization. Next, we consider the time dimension. Because everyone is online all the time, almost everyone, digital applications have access to very fine-grained temporal data streams. They can also accumulate data over very long time spans for analytics because of cloud platforms. One way for modeling abstractions to deal with this extensive timescale and minute granularity is to adopt finite temporal scope. Some variables could be considered invariant within that scope, but would become variable when you go beyond that scope. This kind of finite scoping can also be applied to spatial scopes. So in the timing scope, one example that one could consider would be, can values be treated as beliefs that are resistant to change over the short term, but changeable over a longer time horizon? We also need to consider continuous time as well as discrete time, because some of the phenomena that we are dealing with involve actors continuously adapting to each other. Finally, we need to revisit the notion of actors. In R-star, we make the distinction between agents and roles. Agents are physical and concrete, like people or software, but roles are abstract. In the old days, many applications were in an enterprise context, for example, for business process automation. The focus was to define the relationships among the job roles. Today, digital applications are intensely personal and very human-centered, so the focus is shifting to the physical agent. The physical agent representing technical systems is also changing. There is a learning component in more and more software nowadays. An important research question will be, what kind of properties should be captured at the most abstract level, such as roles in R-star, so that it would transcend the distinction between humans and machines? Should learning be treated abstractly, regardless of whether it is human learning or machine learning? Should there be emotions and values in the abstract actor, or only in human actors? So indeed, it is exciting times for conceptual modeling, especially if you want to face up to the complex social realities that digitalization has gotten us into. There are tremendous resources that we can tap into as conceptual modeling researchers. Social scientists are having a heyday studying the phenomena brought about by digitalization. What we need to do is to come up with the right abstractions so that insight from the social sciences and humanities can be brought into system design. One more thought before I conclude. Social realities matter, not just from a user perspective. System designers and developers are people too. They have strategic interests, values and beliefs, and emotions, just like everyone else. Their values and beliefs may show up as unconscious bias in machine learning models. In developing conceptual modeling techniques, we need to be conscious of how the techniques will be used, where in the life cycle, and by whom. In other words, we should be modeling the conceptual modeling process from a social perspective too, and to debug it just like any other socio-technical design setting. To summarize, modeling is about abstractions. ER modeling gave us a powerful abstraction, enabling us to model all kinds of domains. R-style modeling was an attempt to offer abstractions for applications involving social relationships. Today, the social world has gotten a lot more complicated. We need new abstractions that can help us engage with these complex social realities as we make decisions about systems that are affecting all of us. Digitalization is transforming how we live. It is even threatening to change what it means to be human, as technology is taking over more and more of what used to be unique human qualities and capabilities. Around the world, there are many initiatives raising alarms about the human and social issues that technologies are creating. As far as I know, they are not taking advantage of conceptual modeling techniques. Perhaps it's time that we offer our expertise. But first, we need to do our homework. Thanks to Peter's pioneering work and continuing leadership, conceptual modeling has served as the core foundation for building database applications. Let's work together to build a foundation for conceptualizing and designing socially complex applications. I thank you very much for your attention, and I'll be happy to answer questions here or online. I invite you to join me at the University of Toronto, or from anywhere in the world, to face up to the challenges of complex social realities by advancing conceptual modeling research. Thank you.